Alright, so this time we're doing problem 31 from chapter 4, and the problem says, a 5.6 kilogram bucket of water is accelerated upwards by a cord of negligible mass whose braking strength is 75 newtons. If the bucket starts from rest, what is the minimum time required to raise the bucket a vertical distance of 12 meters without breaking the cord? So we've got a draw diagram. So we got a bucket that has a mass, and we want it to go up a distance of 12 meters, but the cord has a braking strength of 75 newtons. So let's write down what we know first. So we know that the mass of the bucket is equal to 5.6 kilograms. We know that the distance is going to be equal to 12 meters. And we know that the force has to be less than or equal to right the first time. Force has to be less than or equal to 75 newtons. So in order to solve this problem, and we're trying to find the time, so time is what we're looking for. So first we need to find the acceleration, and we know that the acceleration is equal to the force divided by the mass, and this is the net force, so that is actually going to be equal to that's just the net force, total force. So that's going to be 75 divided by our mass, 5.6, and we get an acceleration of 13.39, but we then also have to take into account that the bucket is moving vertically, and so we have to subtract gravity because it's going to be exerting a force and it is an acceleration. And so we find that the acceleration that the bucket can handle after we subtract gravity's pull on it is 3.58 meters per second squared. So then once we have that, we can use the equation that the distance is equal to the initial velocity times time plus 1/2 the acceleration times time squared. We know that the bucket started at rest, so this term goes to 0. We know how far it's moving, so it goes 12 meters is equal to 1/2. Acceleration is what we're looking for, or we know the acceleration from this problem, sorry, from 3.58, we're looking for the time squared. So when we isolate for time, time is going to be equal to 2 times 12 divided by 3.58, and all of that to the 1/2 power, or the square root of all of that. And so from that we can find that the time is equal to 2.59 seconds. So that is the maximum, like that's the smallest the time frame can be for the bucket to go from 0 to 12 meters without breaking the rope.